Hello, 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 hello. Okay, okay. Can hear me, yeah? No problem, yeah? Okay. Yeah. Okay. So yesterday our progress. Yeah. So chemistry chapter 1 and physics 1A. So today we will continue. Yeah. Okay. So for the chemistry, we had the homework of the workbook. Okay. So you managed to try the questions, yeah? Okay, so now we will go through the answers. Okay. Yeah. So if you have the answers, if you want to answer anything, you just shout out. Otherwise, I will go through the answers one by one and then you can compare with your own answers. If you have any questions, you can ask. Yeah. Feel free to stop me anytime. Okay. Yeah. So okay. So first question. Imagine you are a water molecule in an ice cube. Describe what happens to you, giving the reason why it happens as the ice cube is heated up to a temperature of 100 degrees Celsius. Yeah, so basically, in the state of the ice, okay, if we are one of the molecule, so let's say we are here, okay, so let's say we are here, what we experience, okay, as we are going from solid state to 100 degrees Celsius, okay. So basically what we expect is we experience the heating curve. Yeah, okay. So this is what we expect to happen, okay, the heating curve. Okay, yes, so this is what we expect happens. Okay, so we will go through the key points. Okay, so see whether you have it in your answers as well. Okay, yeah, so this is what we expect to answer. Okay, so in ice, if I'm one of the water molecule, so I will be bonded to other water molecules. So now I'm still in the solid state. Okay, so I will be vibrating in a fixed position. Okay, so as we increase the temperature rises, there will be enough energy for some of the bonds to be weakened and begin to break due to increase in vibration. Okay, yeah, so basically as temperature increases, the molecules, they will get more energy, they will vibrate faster. Okay, so the molecules will move further from the neighboring molecules and able to move past them. Okay, so they keep moving faster and faster and then away from each other. Okay, so more away from each other. Okay, so eventually some will break free. Okay, so they can start to move away. Okay, and then temperature continue to rise. More of the bonds will be breaking, and then so finally the boiling happens. Okay, move away from neighboring molecules and move much more quickly at 100 degrees Celsius. Okay, so boiling happens. So basically, it turns to gas, it turns to steam. Little attraction to my neighboring molecules, and I'm able to break away and move a long way away from them. Okay, so this is the process going from solid to liquid to gas. Okay, yeah. So I will move on. So if you want me to stop. If you want to copy something, just let me know. Otherwise, I will just move on. And then if let's say you forget something, you want to copy something, you can go back to the video later to check anything. Okay, so later I will send the video link. Okay, next question. Yeah, so this is quite easy and sometimes it can come up in the exam. So basically, just need to explain the meaning or definition of each term. Okay. So first one, melting. When a substance changes from solid to liquid. Chemical change. Substance change into different substances by chemical reaction. Okay. So a chemical reaction happen. Okay. So a new substance is produced. Condensation. When a gas change into a liquid. Evaporation. When a liquid change into a gas. Freezing. When a liquid changes into a solid. And boiling. When heating of a liquid causes it to vaporize. Okay. Straightforward. Next. Okay. Next, which of the term given in part A best describe what is taking place in each of the following? Okay. So we need to give the name of the process. Okay. Formation of water droplets on the inside of the window on a cold day. Okay. So this one is going from water vapor. Okay. To water droplets. Okay. So going from gas to liquid. Okay. So we know straight away this is condensation. Okay. Another one, formation of liquid potassium chloride from solid potassium chloride using strong heat. Okay. Going from solid to liquid. Okay. So this is straightforward. This is melting. Okay. Next. Okay. Use ideas about kinetic particle theory to describe the following. Okay. Yeah. So kinetic particle theory, we need to remember two key points. Okay. So all matter, okay, are made up of particles. Yeah. So whether it's liquid, solid, gas, whatever their appearance, they don't look at like they make out of particles, but all of them are made out of particles. Okay. So secondly, the particles, okay, are moving. Okay. And then if it is solid, it will be um vibrate at fixed position, and then liquid and gas, they will be moving randomly. Yeah, okay. Okay. Why diffusion does not occur in solid? Okay. So because particles are bonded to one another more strongly than those in liquid and in gases, which do diffuse. Okay. This prevent them from being able to move relative to one another. Okay. So just now we mentioned the, the molecules or the particles of solid, they are fixed at a position. They only can vibrate, but they cannot move easily. Okay. So that's why diffusion cannot really happen for solids. Okay. Next, gases can be compressed more than liquids. Okay, so can be compressed means we can, like, for example, the air in the balloon, we can compress the balloon. Okay, no problem. So that is the characteristics of the gas. Okay, they can be compressed. Why? Because the gas, they are much more spread out than those in a liquid. Okay, yeah, so gas particles, they have a large space, okay, between the particles. So if we compress them, they get closer, no problem. Okay. But liquid, they already very close. Okay. The particles, they're already very close to each other. So it's not easy to compress them. Okay. Gas particles can be squeezed together more than those in a liquid. Okay. which cannot do so because for liquid, the particles are much closer to one another. Okay. Next, it is possible for a liquid to flow, but solid cannot. Okay. So we know that because for the liquid, the particles, they have more energy. They can slide over one another. Okay. So they can move. They can move relative to one another, so they can flow. Okay, but solid, they are vibrating at fixed position. They cannot move, so solid cannot flow. Okay, yeah, what we expect to answer. Liquid can flow because the particles have much weaker bonds between them than those in a solid. Okay, so means then particles in a liquid can move over one another or slide over one another. Okay, next. Okay, yeah. So here, we have a sample of solid substance which has been cooled to -5 degrees Celsius. It was put into a test tube. The test tube was heated in a water bath. The temperature of a substance was taken every 5 minutes for an hour. The result obtained are shown in table 1.1. Okay. Yeah. So basically, we have time with interval of 5 minutes. Okay. And then temperature of the substance increasing over time, which is straightforward. Okay, so here we are practicing to plot the results on the graph grid provided. Okay, putting time on the horizontal axis and temperature on the vertical axis. Okay, so our first step is to label the axis. Okay, so we are saying time on horizontal. Okay, so first we will label the x-axis. Okay, here. Okay, and y-axis will be the temperature. Okay, label the y-axis. Okay. So next part is very important. We need to plan the um scales. Okay, so we want to make sure we have enough space to plot all the points, but um the graph is not too small. So we need to plan our space properly. So if we look at our time, it's going from 0 to 60. Okay, so the most reasonable way to plan our scale will be like this. Okay, hold on. Okay. Yeah, so first we will draw our axis. Okay. And then here will be 0, 10, 20, 30, 40, 50, 60. Okay, so it works out just nice. Okay, so yeah, so this will be a suitable scale so that we can plot all our points at the same time. The graph is not too small. Okay, and then the y-axis. Okay, okay, make it a bit smaller. Yeah. So I will explain one time the steps to plot a graph, and then in the future, once you already understand, I don't need to repeat again. Okay, so second step, we will plan the scales for the temperature. So we're going from -5 to 82. Okay. So okay, so which means we can start at here, -10. Okay, and then here 0, 10, 20, 30, 40, 50, 60. Okay, so we'll see whether it works or not. Okay, so actually it does not really work out because we want 82. So 60 is not enough. So now we need to make the scale smaller. Okay. Okay. So okay, so we'll do something like this. Negative 20, 0, 20, 40, 60. So we need to make sure all the gaps are the same. Okay, and then 80, and then 100. Okay, so this is okay. We covered all the points that we need. Okay, and then now we will plot one by one. Okay, okay, okay. So first point, 0, negative 5. 0, negative 5, it will be somewhere here. Okay, so I'm sure you are very familiar. Okay, 5, negative 1. Okay, so 5, negative 1 will be somewhere here. Okay, 10, 5. Okay, 15, 5. Okay, 27. Okay, somewhere here. Okay, 25, 13. Okay, 30, 28. Okay, here. Um, okay, 35, 45. Okay, somewhere here. Okay, 40, 62. Okay, 40, 62. Here. Okay, and then 50, 79. Okay, so 50, 79, it will be somewhere here. Okay, 55, 82. Okay, 55, 82, somewhere here. Okay, 60, 82, somewhere here. Okay, so this is the curve. Okay, so now we will try to draw a smooth curve that join all the points. Okay, try as much as possible to make a smooth curve. Okay, something like this. Okay, so basically we can see here this part, it will be the melting because the temperature constant, and then this part will be the boiling because the temperature it become constant again. Okay, so now we can look at the marking scheme, okay, to compare with our own answer. Yeah, so this is what we expect to plot. Okay, yeah, okay, okay, so similar to our answer. Okay, yes. Okay, so just need to follow the steps. So first we label the axis. Next, we plan the scale, and then we plot the points. Okay, and then we join them with a smooth line. Okay. Okay, so this is done. Okay, next. What is the melting point? So we mentioned just now is somewhere here. Okay. Okay, so we can get from the table also when it become constant. So we can see it become constant here. So the melting point will be 5. And then here, it become constant again. So this will be the boiling point. Okay. 5 and 82. Okay. So this is our answer. Okay. Next. Okay, so we are familiar with this question. Okay. When the experiment shown in figure 1.1 is set up, a cloud of fine white powder can be seen as the ammonia gas reacts with the hydrogen chloride. Okay, so we know ammonia gas will react with the hydrogen chloride. Okay, so HCl and NH3. Okay, NH3 plus HCl will form the ammonium chloride. Okay, so this will be the fine white powder. Okay, which of the particles will move faster? Okay, so we have done this question before. We know that for the diffusion, the lighter particle will move faster. And then last time we already done this calculation. We know that ammonia is, okay, Mr of hydrogen, Mr of nitrogen, molar mass. Okay, so we can get this from the periodic table, chloride. Okay, hydrogen is 1, nitrogen 14, chloride is 35.5. Okay, so this one will be 1 plus 35.5, 36.5 gram per mole. Okay, so this one will be 14 plus 3, 17 gram per mole. Okay, so this one will be lighter. Okay, so we expect the ammonia will be moving faster. Okay, at which point A to E along the tube will the white cloud be seen? Okay, so where the product will form. Okay, explain your answer in terms of movements of the particles. Okay. So, okay, so we know ammonia will be moving faster. So of course it will not form at here. Okay, so ammonia will be moving more. Okay, okay, and hydrogen chloride will be moving less. Okay, so we expect the product, it will be formed somewhere here. Okay. Okay, so our answer is point B. Okay, because both hydrogen chloride and ammonia, they move randomly along the tube, but ammonia particles are lighter. They will move faster and further along the tube than the HCl particles. Okay, yeah. So feel free to stop me if you have any questions, need any clarification. Okay, how do the particles of hydrogen chloride and ammonia gas move along the tube? Okay, so what kind of movement they have? So basically, they are moving by diffusion. Okay, so they move along the tube randomly because they are gas particles, so they will move randomly. What happened? They will be colliding with other particles. They will run into other particles and they will collide with the wall of the tube. Okay, so they will collide with the wall of the tube as well. But the particles of ammonia, they will be moving faster because they are lighter. Okay. Next, exam style questions. Okay. Yeah, okay. Give two properties shown by solid, liquid, and gas. Okay, so we are very familiar with that. The characteristics of solid, liquids, and gas. So solid, we can answer. Example, cannot be compressed, has a fixed shape, expands on heating. Okay. Liquid, we can say that it can flow and take up the shape of the container, and it can only be compressed a little bit. Again, the volume will increase when heated. Okay, gas. It can be compressed easily, it can flow easily, and then it will fill the whole volume of the container. Okay, next. Okay, draw diagrams in the boxes provided to show how the particles are arranged in each of the physical state, what we expect them to look like, solid, liquid, and gas. Okay, we are very familiar with that. Okay, like this. Okay, what we expect to see. Okay, so we need to know how to draw these um, diagrams. It can come up in the exam. So you need to make sure all of the circles, they are same size. Okay, and then for solid, they will be arranged in regular order. And then for liquid, they will be irregular. And then for gas, they will be spaced out, okay, from each other. Okay, next. Okay. So melting and boiling points of five substances are given. Okay. Yeah, so this one is a similar questions that we have in the textbook. Okay. Um, yeah. So this one maybe you can try. So this one they're asking which elements is or are a gas at room temperature. Okay. So this one you maybe you can try. One answer. One answer. Which element is a gas at room temperature? Okay, have a try of this question B1. Have a try. Which element is or are a gas at room temperature?
Oxygen.
Correct. Excellent. Okay. Try the next one. Okay, which elements are solid at room temperature? Okay, so this one there are two answers. Okay, have a try.
Phosphorus and iron.
Correct. Okay, next one. The question is a little more complicated. Okay, have a try. Which of the elements will boil first if the temperature is raised from room temperature? Yeah, okay. Which of the elements will boil first?
Phosphorus. Oh
Eh,
wait, no. Oxygen.
okay, you see, at room temperature is 25 degrees Celsius, right? So
Yeah.
oxygen is already a gas. You know what I mean? Yeah,
Mm,
so oxygen is already a gas. So what will be the other answer?
it's bromine.
Yes, correct. Okay, because bromine has the lowest boiling point. Okay, so if we start heating at 25 degrees Celsius, bromine is the one that will boil first. Okay, excellent. Okay, next. Okay, so this one we need to use kinetic particle theory to describe the following. Okay, so as we mentioned before, kinetic particle theories, two key points, all matter, okay, are made of particles. Okay, so the particles, they are moving all the time. They are moving all the time. Either they are solid, they are vibrating. Okay, if they are liquid or gas, they will be moving randomly. Yeah. Okay. So based on our understanding on the kinetic particle theory, how can we explain these situations? Okay. So if we are walking along the street in front of a coffee shop, it is possible to smell the coffee. Okay. So this one we can totally explain with kinetic particle theory. Why? Because we know that the coffee smell. Okay, the molecules of the coffee smell, they are made of particles, small particles, and then they are moving randomly. So if the smell is produced in the coffee shop, slowly it will spread out to the street. Okay, so we can smell it on the street. Okay, so what we expect to answer. Okay, gas particles from the coffee shop, they are moving randomly, okay, from the coffee shop. They will be colliding with other particles in the air. So they will be spreading out, okay, until they reach you. So this is the process of diffusion we are talking about. Okay. So which telling us the kinetic particle theory can explain why diffusion happens. Okay, next. When laying railway track, gaps have to be left between the lengths of the track. Okay, so I'm not sure whether you are familiar about the railway tracks. Okay, so maybe I can try to find a picture quickly. Okay. Uh, okay. Okay. Hold on.
Yeah.
Yeah, you. Okay, hold on. Wait. Okay, so maybe this is a good picture. Okay. Okay, so first we look what a railway looks like. Okay. Okay, so this is what it looks like. Okay, so this is a railway track. If we take the train, okay, so we can see the railway track. Okay, now if we look closely, uh, there are gaps. Okay, okay, there are gaps in the railway tracks. Okay, okay, so this is the gap. Okay, so we try to think why we need this gap. Okay, and then we try to relate it to kinetic particle theory. Okay, why we need to have the gaps? Because the particles, the solid, it will expand if we heat it up. Okay, yes, because the particles, they are moving faster. Okay, so when they're moving faster, they will expand. Okay, so this is related to kinetic particle theory as well. Okay, everything is made of particles. If we heat them up, they will move faster and then they will expand. Okay, so if we do not have a gaps, then the railway tracks will start to bend. Okay, when they expand, they have nowhere to go, so they will bend. So we don't want this to happen. Okay, so that's why we will leave a gap to leave a space for the railway track to expand. Okay, so that's why we leave a gap. When temperature rises, the steel tracks will expand. The gaps will allow the tracks to expand without buckling the railway lines. Okay, so we don't want them to buckle or bend. So that's why we have these gaps. in the railway tracks. Okay, next. Okay, when a tea bag is placed in a cup of water, the color of the water changes. Okay. Okay, let me quickly find a picture. Uh, okay. Yeah, so we are very familiar with that. Okay. Yeah, so we know that when we put a tea bag, okay, it will slowly diffuse, okay, the particles of the tea, okay, the molecules in the tea, they will slowly diffuse into the water, okay, so finally we will get a uniform color of the tea, okay. So as I mentioned just now, this is a process of the diffusion, okay. Again, kinetic particle theories, everything is made of particles and then they move randomly. The particles of the tea, they move randomly and then they collide with water molecules in the water and then they will diffuse from the tea bag until eventually all of the water in the cup changes color as the tea dissolves. Okay. Next, in a cold weather, the amount of water found running down inside of windows increases. Okay. So what we are talking about here. Okay. Okay. This is the explanation. Water vapor inside the house caused by central heating, hot water, and people breathing condenses onto the glass of windows, which is colder. Okay, so this is talking about condensation can happen. Okay, when there is a difference of temperature. Okay, next. A bubble of methane rises from the bottom of the Pacific Ocean. As it rises, the bubble gets bigger. Okay, so what we are talking about here. Okay, so this one is talking about a change in pressure. Yeah, okay. So we did talk about this briefly yesterday. Ah, yes. Okay. What happened to the volume when we increase the temperature? What happened to the volume when we change the pressure? Okay. So in the ocean, the temperature is mostly constant. So we are not really doing anything with the temperature, but the pressure changes. Yeah, okay. So when we change the pressure, what happens? Okay. So when we increase the pressure, volume will decrease. Okay. When we decrease the pressure, volume will increase. Okay. So now, if we look at our question, so this is the ocean. So this is the bottom of the ocean. This is the surface. Okay, so we are saying that we have a small bubble rising up, okay, to the surface. Okay, so we are saying that it gets bigger and bigger. Okay, why? Uh, okay, that is because as we are going up, the pressure decrease. Okay, there's less water as we going up. The pressure decrease, so the volume is increasing. Okay. Yep. Okay, at the bottom of the ocean, the bubble has a large amount of pressure around it due to the depth of water and has an equal interior pressure caused by the methane molecules. As the bubble rises, the external pressure decreases and the relative greater interior pressure of the gas bubble causes the volume of the methane bubble to increase. Yeah, okay. So we can see here. Okay. So as we decrease the pressure, the particles, they have more space to move in. Okay. So basically, the volume will be increasing. Okay. Next. Okay, we have a weather balloon full of helium gas is prepared to take off. The amount of helium gas in the balloon has to be carefully monitored before it is sealed. Okay, as the balloon rises, what happens to the external pressure? Okay, so this is our land. Okay, so we're trying to release the balloon. Yeah, okay. So we're trying to let it go up. Okay, so we need to think what happened to the pressure. So you may recall maybe from like geography or something like that. So if we or science, the atmosphere is getting thinner and thinner. Okay, as we go up from the surface of the land, there is less and less air as we go up. Okay, so the air is getting thinner and thinner, so the pressure will be decreasing. Yeah, so same thing. When the pressure will be decreasing, external pressure is going down. So we expect, so first step, we are saying that the pressure is decreasing. Okay, so what happens to the balloon? Okay, so as we mentioned before, pressure decrease, volume will be increasing. Okay, so we expect the volume of the balloon will be increasing. Okay. Explain in terms of kinetic particle theory. Yeah, so you can see this type of question, it comes up a lot. Explain in terms of kinetic particle theory. Okay, why the volume of the balloon changes the way you have stated. Why? Because again, kinetic particle theory, all matter, okay, made of particles. Okay, and then they, in this case, we have a gas. Okay, so the gas particles, okay, they are moving randomly. Okay, so when they are moving randomly, when we the temperature staying the same. Okay, so when we reduce the pressure, okay, so basically they have more space to move in. The gas particles, they have more space to move in. The volume will be increasing. Okay, so that's why the balloon is increasing. Okay, as external pressure, outside pressure decreases, the particles of helium gas inside are still colliding with the inside surface of the balloon, so causing the balloon to increase in volume. Okay. Next, what happens to the external pressure as the balloon rises? Sorry, external temperature. Okay, so now we are talking about the external temperature. Okay, we expect it to get colder and colder. Yeah, so when we go up the height, okay, if we climb a mountain or something like that, it feels colder. So when we go up, external pressure will decrease. Okay, so now we come back to the notes. Okay, when temperature increase, volume will increase. Okay, yeah, so if we increase the temperature, the volume will increase because the particles are having more energy. They can move faster and take up more space. Okay, so now in this case, the temperature is decreasing. So we expect the volume will be decreasing also. Okay. What effect will this have on the volume of the balloon? Explain your answer using kinetic particle theory. Okay. So what we mentioned just now. Okay. External temperature decrease. This will be cooling down the gas in the balloon. So the particles will be losing kinetic energy. They have less energy. They will collide with the inside surface less violently. So basically, it will lead in a decrease in the volume. So the volume will be decreasing. Okay? Yeah. Okay. So with this, we have done all the questions in the workbook. for the chapter 1 chemistry. Okay, so we can look at our progress here. Yeah, so now the chemistry. Okay, so we are done. Okay. Yeah. Okay. So what we're going to do next is physics. Okay. Yeah. So now the chemistry, we finish all textbook and workbook. The practice, everything we finish. So now we'll return back to this physics 1A. So yesterday I mentioned quickly about the homework. Okay, so the physics workbook. Okay, so we can try to go through together. Okay, yes, this workbook. Okay, so I was asking to do 2 pages. You managed to do the questions? Okay, so if you have the answers, you can check your own answers. Okay, so I will go through the questions answers now. Okay, so first one, state the number of millimeters in each measurement. Okay, so you see here, this part we want to change from cm to mm. Okay, so this part we want to change from meter to mm. Okay, so I'm sure you are very familiar with this, how to do that. Okay, so first we know that 1 cm is equal to 10 mm. Okay, so which is telling us, okay, if we're going from cm to mm, we need to multiply by 10. So going from mm to cm will be divided by 10. So here, we want to go from cm to mm, so which means everything multiplied by 10. Okay, so this is what we expect to answer. Okay, 2 cm equals to 20 mm, 0.4 cm equals to 4 mm, 12 cm equals to 120 mm. Okay, yeah, so if I'm going too fast or too slow, if I'm like talking about something you already know, you can just stop me. Okay, so yes. Okay, meter to mm. So first we need to know 1 meter equals to okay, let's leave some space. Okay. 1 meter equals to 100 cm. Okay, and then here 1 cm equals to 10 mm. Okay, so which means 1 meter to cm. Okay, meter to cm multiply 100, cm to meter divided 100. Okay, so now we want to do okay, so now we'll do the next step. Okay, so cm to mm. Okay, so cm to mm, this is multiply by 10. Okay, okay, multiply by 10, so here will be divided by 10. Okay, so that will give us 1000 mm. Okay, so which is telling us that 1 meter equals to 1000 mm. Okay, so which means what we need to do, meter to mm multiply 1000, mm to meter divided by 1000. Okay, so now we can try to answer the question. So this part will be meter to mm multiply 1000. Okay, 1, 2, 3. 1, 2, 3. Okay, So which will give us the answer of 500 mm and 1400 mm. Okay. Next, another unit conversion. Very straightforward. Okay. So this is cm to meter. Okay. So just now we already know 1 meter equals to 100 cm. Okay. So which means meter to cm multiply 100, cm to meter divided by 100. Okay. So which means all of these we need to divide by 100. Okay. So cm to meter. Okay. So divide by 100. 1, 2, 1, 2, 1, 2, 1, 2. Okay. So which will give us the answer of 15 meter, 1.5 meter, 0.15 meter, and 0.015 meter. Okay, straightforward. Okay, give the number as a power of 10 with one figure before the decimal points. Okay, so this one means we need to give the number as a standard form. Okay, so I'm sure you are very familiar. What it means by standard form. So we have a number here. Okay, so this one will be more than 1. Okay, more than 1. Okay, less than 10. Okay, yeah, okay. So x, something like that. Okay, so multiply with 10 to the power of something. Okay, so example 2.5 10 to the power of 3. Okay, so we cannot have 250 10 to the power of 3, cannot. Okay, so this number here must be more than 1, less than 10. Okay, and then we also cannot have 0.25 times 10 to the power of 3, cannot, must be more than 1. Okay, so this is the rule of the standard form. Okay, so here we need to, so this is 1000, so we need to move a decimal point so that it become yeah, so actually it can be equal than 1. Okay, more or equal than 1. Okay, so we need to move until is more than 1, less than 10. Yeah, okay. So now we should move 3 places. 1, 2, 3. Okay, so now we have 1. We move 3 times, 10 to the power of 3. Okay, yeah. Okay, this one we need to move 1, 2, 3, 4, 5. Okay, so now it's more than 1, less than 10. Okay, 2.25, 10 to the power of 5. Okay, so here we need to move 1, 2. Okay, so I assume you are very familiar with this. If anything not clear, you just stop me. Okay, 6.5, 10 to the power of 2. And then 1, 2, 3, 4. Okay, 1.5, 10 to the power of 4. Okay, next. So this is the other way around. Standard form to full number. Okay, so this is 1 times 10 to the power of 4. So which means 1, we need to move 4 decimal place. 1, 2, 3, 4. Okay, so which will give us 10,000. Okay, this one, 10 to the power of 2, we need to move 2. 1, 2. Okay, 250. Okay, this one we need to move 6. 1, 2, 3, 4, 5, 6. Okay, so our answer will be 1,500,000. Okay, so this one we need to move 8 position. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, which will give us 35 followed by 7 zeros. Okay, next, give each decimal as a power of 10 with one figure before the decimal point. Okay, so this one is same thing. Okay, But when we have decimals, the power is negative. Okay. So now again we move 1, 2, 3. So now is more than 1, less than 10. Okay. 1, 10 to the power of negative 3. Okay. So when we have negative number, the power is negative. I mean, when we have decimals, the power is negative. So this one will be 1, 2. Okay, 2 to the power of negative 2. So this one will be 1, 2, 3. Okay, we move until here is enough because now it become 1.2. It's good enough. Okay, 1.2, 10 to the power of negative 3. And then this one, okay, we move until 1, 2 is enough because now it's 1.02. More than 1, less than 10. Okay, 1.02, 10 to the power of negative 2. Okay, now give each fraction as a power of 10 and as a decimal. Okay, we'll do decimal first. Okay, it's easy. Divided by 100. Okay, divided by 1000. Okay, divided by 10,000. Okay, so this one we can multiply by 2 first. So this will be 10,000. Okay, and then 8 divided by 10,000. 4 position. So this one also 4 position. Okay. Okay, so this will be our decimals. Okay. 0 0.01, 0 0.002, 0 0.0003, 0 0.0008. Okay. So change to power of 10 standard form. Okay. So if we do it correctly, that will give us, okay. So now we need to move the decimal point, this one, 1, 2. So to give 1, 1, 2, 3, to give 2, 1, 2, 3, 4, to give 3, 1, 2, 3, 4, to give 8. And then this one we move 2 times, power of 2, we move 3 times, negative 3, move 4 times, negative 4. This one also move 4 times, negative 4. Okay? Yeah. So this is how we change to the standard form. Okay. Next, okay, state each length as a power of 10. Okay. In meters. Okay, so we need to do 2 steps. So first we change to meter. Okay. So just now we already know 1 meter equals to 1000 mm. So mm to meter will be divided by 1000. Okay. 1, 2, 3, 0 0.005 meter. Okay, so now okay, we'll do this step first for all of them. Okay, and then we have 1 meter equals to 100 cm. Okay, so cm to meter divided by 100. Okay, 1, 2. Okay, 0 0.5 meter. Okay, 5 km. 1 km equals to 1000 meter. So km to meter multiply 1000. Okay, 1, 2, 3. So this will be 5000 meter. Okay, so now we will change to the standard form. Okay, so here we need to move 1, 2, 3 to give 5. Move 1 to give 5. Okay, so this one we need to move the other way around. 1, 2, 3 to give 5. Okay, so this one we move 3 places, negative 3. 1 places, negative 1. This one we move the other way, 3 places, like this. Okay? Yeah, so this will be our answer. Okay, in meter. Okay, next, state the number of significant figures. Okay, so this one maybe you can try. This one should be easier. You know how to do that. Okay, so question 8a, how many significant figures? You can tell me.
Mm, 3,
Correct. Excellent. Okay. B.
2,
Yes. C.
2,
Correct. Yes. Okay. Number 9. Okay, so this one should be easy as well. Okay, round 1.263 to one significant figure. Okay, so you can try it. Okay, so can remember how to do the rounding, yeah? Okay, round 1.263 to one significant figure. Okay, have a try. Okay, can remember how to do the rounding, yeah? 1.263 to one significant figure.
1,
Yes, correct. Okay. B, two significant figures.
1.3,
Correct. Excellent. Three significant figures.
1.26.
Correct. Excellent. Okay, now the rest it should be quite easy also. Okay, calculate the area of rectangle with a length 6 cm and width 4.5 cm, giving your answer to an appropriate number of significant figures. Okay, so we have a rectangle, okay, 6 cm and 4.5 cm. Okay, so the area will be straightforward. Length multiplied by the width, which is 6 multiplied 4.5. Okay, so if we do that, we'll get 27. Okay, so now appropriate significant figure, we can see this one is 6.0. So this two significant figure. This 4.5 also two significant figure. So the answer will also be two significant figure. So 27 is just nice, no problem. Okay, so we just give our answer as 27. Okay, next. Okay, calculate the area of a right angle triangle with the side 30, 40, 50 cm. Show your working. Okay, so if we have a right angle triangle, so given 30, 40, 50, so we expect will be something like this. 50 must be the hypotenuse, 30 will be here, 40 will be here. Okay, so now the area, okay, we need to recall the area of the triangle, which is 1/2 base times height. Okay, so this is base, this is height. Okay, so which means we don't care about this one. This is there to confuse us. So our answer will be 1/2 multiply 40 multiply 30. Okay, so which will give us the answer of 600 cm squared. Okay, straightforward. Okay, next, calculate how many bricks of size 5 cm multiply 2 cm multiply 3 cm a child would need to build a rectangular block of dimension 15 cm, 15 cm, 10 cm. Show your working. Okay, so we have these bricks. Okay, okay, of 5 cm, 2 cm, 3 cm. Okay, and then we need to stacking this brick to make a big block. Okay. Yeah. We need to stacking this brick to make a big block. Okay. Something like that. Okay. Okay. Example. Okay. So we need to stacking this brick to make a big block. Okay. So we are asking if the big block is 15 times 15 times 10, this one, small block, how many? Okay. How many of the small blocks that we need? Okay. So what we need to do is this. Okay. So we need to take the volume of the large block divided the volume of the small block. Okay, so that will give us, we need 75 small bricks to make the big block. Okay, so these all seems like math questions, but this is kind of related to physics as well. So sometimes you will get this kind of question. Okay, next one. Okay, student records the time taken for 20 complete swing of a pendulum to be 32 seconds. Calculate the period. Okay, so when we want the period means we want time taken for one swing. Yes. Okay. So we know we have 32 seconds for 20 swing. Okay. So if we divide that, that will give us 1.6. Okay. So the period is 1.6 seconds for one swing. Okay. Yeah. Okay. So as we can see, this unit 1A for physics is quite a big topic. So yeah. So far we only finish 1.1. Okay. So it should be going from, if we look at the contents, yes. So the unit 1A, it should be going from 1.1 to 1.4. So at this moment, we just finished 1.1. Okay. So it is a big topic. So we will keep going for a bit. Okay. For this physics. So this workbook, okay. So we will stop at this position. Okay. Then we will learn the 1.2. So start from here, it will be 1.2. We'll learn the 1.2, then we will come back and do these questions. Okay. Uh, okay, so now I will close first. Okay, so here we make some progress on the workbook. So now we will continue the 1A. Okay. For the textbook. Okay. Okay. So yesterday we just complete the notes for the 1.1, everything. Okay. So now we will move on to 1.2. Okay. So 1.2 is about motion. So I'm sure you are very familiar with this topic as well. Okay. So we will go through it. Okay. Yeah. So straightforward. What is speed? Distance travel per unit time. Okay. Velocity is a speed in a given direction. Okay. So speed, we just concern how many meter. Okay. This is scalar. Okay. So velocity, we want to know how many meter and also the direction. So the velocity is vector. Okay. Yep. If someone sees a runner running 5 meter per second in a northerly direction, then the runner speed is 5 meter per second and their velocity is 5 meter per second north. Okay. So you can see the difference there. So for the velocity, we will give the direction. Okay. So how to calculate speed? So this one you are very familiar. Speed equals to distance divided by time. Yeah. Speed equals to distance divided by time. Okay. So sometimes we also calculate average speed. Okay. So sometimes we are going faster, we are going slower, and then we are faster again. So we keep changing our speed. No problem. In the end, we can calculate the average speed. Okay. So how to calculate the average speed? Total distance traveled divided by the total time. Okay, straightforward. Acceleration. Okay, so acceleration is how fast the velocity is changing. Okay, velocity divided by time. Okay, so acceleration. Okay, so normally we will take v minus u over t. Okay, so v is the final velocity. Okay, u is the initial velocity. Yeah. Okay. So final velocity, initial velocity. So let's say we start at 5 meter per second, and then we speed up to 10 meter per second. So and then we take 2 seconds. Yeah, we take 2 seconds to do that. So our acceleration will be the final velocity, which is 10 minus 5 initial velocity divided by 2 seconds. Okay, 2.5 meter per second squared. Okay, yeah, so we need to remember the unit meter per second squared for acceleration. Negative acceleration is called deceleration, means we are slowing down. Okay, next we need to understand how to interpret the graphs. Okay, so we have two types of graphs. First, we have distance time graph. Okay, so distance time graph. Okay, so we need to know what it means, the line. Okay, so if so distance. So let's say this is 0. This is like 20, and then this is 30, for example. Okay, you see, when it has horizontal line, means it's not moving because the distance is still staying at 0. Okay, so when we have horizontal line, means at rest, not moving. Okay, so when we have straight line, means constant speed. Okay, because the distance is increasing uniformly. Okay, so if we have straight line, means constant speed. Okay, horizontal line again is not moving. Okay, it stopped at the distance of 20 meter, and then it just stay there. Okay, at rest, not moving, and then it start moving again, straight line, constant speed. Okay, so this is what it means when we have horizontal line, means not moving. When we have straight line, means constant speed. Okay, so we can have a situation. Let's say we have horizontal, and then we have like this. Okay, so when we have straight line, it's constant speed. When we have this curve, means the speed is changing. Okay, so this one, normally we don't need to concern about this in IGCSE. IGCSE, mostly we will look at constant speed. So this one, changing speed. So means it's accelerating. Okay. Okay. Yeah. Okay. Another thing we need to concern is the gradient. Yeah. Okay. So you see, here we have constant speed. Here we have constant speed. This one, the slope is higher. So you can see this is the lower slope. Okay, so this is steeper. Okay, so when we have steeper, means the speed is higher. Okay, higher speed. Okay, when the gradient is greater, means it has a faster constant speed. Okay, yeah, gradient will be equal to the speed. Okay, so for the calculation, if we calculate the gradient, distance divided by the time, so that will give us the speed. Okay, so these are the information that we can get from a distance time graph. Okay, next. Oh yes, calculating the gradient. Okay, so how to calculate the gradient? We take this one divided by this one. Okay, so in our case, okay, it will be the distance divided by the time for this triangle. Okay, yes, so this one is another situation I mentioned just now. If it is not a straight line, if it is a curve, then it's not constant speed. Okay, and then we have two situations. We have, okay, let me sketch like this, is clearer. Okay, we have one situation is like this. Okay, and then we have another situation is like this. Okay, so this is distance time, and then this is distance time. Okay, so we are saying that this is accelerating. Okay, acceleration. This is deceleration. Okay, acceleration means the speed is going up. Deceleration means the speed is going down. Okay, why we say like that? Why? Because this one, we can see that the gradient. Okay, the gradient of the graph is increasing, means the speed is increasing. Okay, so this one we can see the gradient. Okay, is decreasing, it's getting less steep. So the gradient is decreasing, so the speed is decreasing. So that's why we say this is deceleration. Okay, quick look at the notes. Okay, as the speed is increasing, the object is accelerating. Speed decreases, the object is decelerating. When speed changes, the distance time graph, it will produce a curve. Okay, so as we see here. Okay, so if we have upward curve like this one, means it's accelerating. If we have a downward curve like this, means we are decelerating. Okay, so we need to know this interpretation of the distance time graph. Okay, next. Yes. Speed at any time. Okay, so now, okay, let me, okay, okay. This is our distance time graph. Okay, so we are saying that the speed is changing. Okay, you see, just now, this is a straight line. This is a straight line. We can calculate the gradient easily. So we just take this divided by this. Okay, let's say this is 20 to 30, so this will be 10. Let's say this is like 30 second to 40 second, so this will be 10. So the speed will be 10 divided by 10. Okay, so we can get the speed easily if it is a straight line. Okay, how about if we have a curve? How we get the straight line? Okay, I mean how we get the speed. Okay, so let's say we're going from 0 to 10 to 20 to 30 second. Okay, how about I'm interested the speed at 10 second, and then I'm interested the speed 30 seconds, what do? We will draw a tangent. Okay, so example. Okay, so we'll draw a tangent. It's just a line that is at 10 seconds. Yeah, we just draw a tangent. And then we will calculate the gradient of this tangent. Okay, and then let's say we want the gradient at 30. Now again, we will draw a tangent. Okay, just a line that is touching that point. Okay, so this is the tangent. Okay, and then we will calculate the gradient of this tangent. Okay, so this is how we work out the speed when we have a curve. Okay, yes. Yeah, so here there is another example. So let's say we want the tangent at this 3 seconds. We'll draw a tangent like this, and then this tangent we will find the gradient. Okay, so example here. Okay, speed at time 3 seconds is 20 meter per second. Okay. Okay, next, determining the motion of an object from data. Okay, so sometimes if we are given the time and distance data, we can determine how what is going on. Okay, yeah, what kind of motion? Yes. So if we have a constant speed, the distance will be increases the same amount each time. So this is a situation for the constant speed. Okay. So the time going from 0 to 2, 2 to 4, and then each time is increased by 5, plus 5, plus 5. Okay. The distance is increased by the same amount. This is what we call constant speed. Okay. So when it is stationary, so we can see here, 6 seconds to 8 seconds, the distance is stay the same. When the distance is staying the same, it's not moving. This is what we call stationary. Okay, so this is changing speed. Okay, so we can see this one is plus 2 plus 2. See this one plus 2 increase same amount. Okay, this one plus 2, this one plus 2 plus 6. Okay, for the same amount of time, the distance is changing, the distance is increasing. So this is speeding up. This is changing speed. Okay. When it's stationary, the distance will remain the same. This situation here. Okay. When the distance is increasing for different amount for equal time, the speed is changing. Okay. So this example of changing speed. So if we plot a graph, it will be very clear. Okay. Even without plotting a graph, suppose we can work it out as well. Okay, so the next type of graph is the speed time graph. Okay, so the speed time graph and the distance time graph, sometimes it look very similar, but it will give us a different information. It will give us different information. Okay, so first, okay, let me just show the distance time graph side by side. Okay. Okay. On. Okay, this a
Yeah.
little bit messy. Let me open again. Okay. Okay. Yeah. Okay. 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 Now we compare. Okay. Distance time and speed time. What's the difference? Okay. Okay. Yeah. So just now we already saw this distance time graph. Okay. At first, when it is horizontal line is at rest, straight line, constant speed, horizontal, not moving, straight line, constant speed. Okay. So this is a distance time graph. When we have a speed time graph, it's different. Okay. You see, when we have this straight line, it's not a constant speed. No, it's acceleration. Okay. When we have a horizontal line, this is stationary, but this it means constant speed. Okay. And then this line going down is deceleration. Okay. Deceleration, once the speed it goes to zero, and that is not moving. Yeah. Okay. So the speed time graph and the distance time graph is giving different information. So we need to be careful about that, not to confuse. Okay. And then another key point is the area under the graph. Okay. If we have a speed time graph, the area under the graph will give us distance. Okay. So we need to remember that. Area under the speed time graph is the distance traveled. Okay. Yes. So just now we discussed this. The more steep, okay, the speed is increasing. So this one, same thing. This one, the gradient higher, the more the acceleration. Same thing. Okay. Steeper the gradient of the speed time graph, the greater the acceleration. Okay. So in this case, you see this line is more steep than this one. So we are saying that the deceleration is happening more than the acceleration. Okay. Deceleration is greater than acceleration. Okay. And then we have a very special number, which is acceleration of free fall. Okay. So this is the acceleration that is due to the gravity. Okay. So anything on the surface of Earth will be attracted by the gravity. Okay. And then the strength of the gravity is quite constant. So basically, it will cause an acceleration of 9.8 meter per second. So it's quite constant. Mostly the same on the surface of Earth everywhere. Okay. Now, same thing. Calculate the acceleration using the gradient of the speed time graph. Okay, so we can do that. Okay. Yeah. So so basically, if we want to calculate the acceleration, we take the change of the speed divided by the change of the time. Okay. So later we will have some example. Okay. So this one is the how the speed changing when we drop an object on the surface of the earth. Okay. So this is our earth surface. If we drop an object, okay, how the speed is changing. Okay. How the speed will change. Okay. So we have two scenario. One is with no air resistance. One is with air resistance. Okay. So with a so if we have no air resistance, okay, so basically we just have a constant acceleration. The acceleration is just staying constant. So we just have a straight line if we have no air resistance. Okay. So if we have air resistance, what is happening? So at first, the object it start to drop. Okay, so now the acceleration is 9.8 meter per second. Okay, so as it is starting to drop, it will face air resistance. Okay, so it will have a down force, which is gravity. Okay, and then it will have the up force, which is air resistance. Okay, so let's say yeah, so the gravity will be so let's say is 50. Okay, so let's say this is 20 Newton. Okay, so 50 Newton and 20 Newton, so which means we have a resultant force of 30 Newton. Okay, so which means at first it is just 50 Newton down when there is no air resistance. So at first 50 Newton down, air resistance is 0. So it's 50 Newton down. Okay. But now when we start to have the air resistance, the resultant force decrease. Okay. We know this formula, F equals to ma. Okay. So mass is constant. So mass of the object, it just remain the same. Let's say it's 1 kg. Okay. But when the force is decreasing, the acceleration is also decreasing. So that's why we see here the curve is changing. Yeah, okay. So that's telling us it's decelerating. So when we have air resistance, it will affect the movement of the object. Okay. No air resistance and with air resistance will affect the movement of the object. So it will keep dropping. Okay. So if it will keep dropping. So let's say this is 50, 20, and then after some time, so when the object move faster, the air resistance will increase. So now we have 50, 30. Okay. After some time, it will become 50, 40. And then eventually it will become 50, 50. Okay. So now the resultant force is 20 Newton down. This resultant force is 10 Newton down. This resultant force is 0 Newton down. Okay. So we can see the force is decreasing, force decreasing, acceleration decreasing. So we can see this going flat and flat and flat and flat until it is horizontal. Okay. When it's horizontal, it's this situation. Okay. When the up force and the down force is balanced out. Okay. When the up force and down force is balanced out, the force is equal to 0. Resultant force equals to 0. So now acceleration equals to 0. Remember, horizontal line is 0 acceleration. So now we have a constant speed. Okay, so this is what we call terminal velocity. Okay, so first time you listen to this, it may be a little bit confusing, but as you hear it a few more times, it will start to make sense. Okay, so this is the concept of if we okay, if I find a picture will be easier. Okay. Yes. Hold on.
Yeah.
Okay. Yes. Okay. So this is another scenario we can consider. Okay. Yeah. So when someone is jumping a parachute, okay. So why this terminal velocity is increasing when someone is jumping a parachute? Okay. Because of the gravity, his speed is increasing. Okay. Faster. Okay. His speed is increasing, but he also have air resistance. He got the gravity and then he also get the air resistance. So the speed is decreasing, okay? But at some point, the up and down force will be balanced. he will reach a terminal velocity, but his speed is still like extremely high. If he keeps going down like this, he will die because it's too fast. Okay. So what he will do is at this point, he will open the parachute. Okay. So when he open the parachute, he will have a very high resistance, very high air resistance because the parachute is big. Okay. So when he has a very high air resistance, he will slow down a lot. He will slow down a lot until he reach a new terminal velocity, which is quite low. And then if he landing at this low speed, hits the ground, that will be safer. Okay, so that is another example of this no air resistance and with air resistance situation. Yeah, so this is all of the explanation. Yeah, so without air resistance, the gradient will just be constant and equal to 9.8. So we just get a speed time graph. It's just straight line. Okay, so this one is no air resistance. Okay, so with air resistance, it will reach to a terminal velocity. So this is with air resistance. The acceleration will decrease, the gradient will be decreasing, the speed will be slowed down. Okay. At first, when the speed is slow, there will be no air resistance. Okay. But as it is speeding up, there will be increasing air resistance. Okay. When there is a high speed, there will be high air resistance. And then it will balance out the weights of gravity. Then there will be no acceleration reaching terminal velocity. Okay, next. Okay, example of question. A runner complete 800-meter race in 2 minutes 30 seconds. After completing the first lap of 400-meter in 1 minute 10 seconds, find their average speed for the last 400-meter. Okay. Yes. Okay. So we want the average speed for the last 400-meter. Okay. Okay. So basically total is 800-meter. So 400-meter, 400-meter. Okay. Okay. Total is 2 minute 30 second. Total 2 minute 30 second. Okay. First lap 400-meter. This is 1 minute 10 second. Okay. Okay. Excuse me. So which means we have 2 minute 30 second minus 1 minute 10 second. Okay. Okay, which means this part, okay, it takes 1 minute 20 seconds. Okay, so we want the average speed. Okay, so average speed is equals to distance divided by time. Okay, so the distance is 400-meter. Okay, so we know the unit is meter per second. So this one we need to change to second. 60 seconds plus 20 seconds, which is 80 seconds. Okay, divided by 80 seconds. So that will give us 5 meter per second. Okay, so that's the concept for this question. Yep. Okay, so 5 meter per second. Okay, another sample question. Okay, so first, yeah, for this kind of graph, the first thing we must check whether it's speed time graph or distance time graph because the interpretation is different. Okay, so let me just copy the speed time graph. Yes. Okay. Okay, so the interpretation of the speed time graph. Okay, so we need to remember what it means by the straight line, what it means by the horizontal line. Okay, yeah, okay. So now, okay, so we need to know part A, part B, part C, what it means. Okay, so straight away we know part A is acceleration. Okay, part B, constant speed. Okay, okay, part C is deceleration. Okay, calculate the total distance covered. Yeah, okay. So as mentioned before, total distance covered will be area under the graph. Okay, so which means we need to calculate this area. Okay, yeah, we need to calculate this area. So we can see that this is a trapezium. Okay, area of trapezium. Can remember? Okay, so let's say we have a trapezium. Okay, so this is the height of the trapezium, AB. Area of trapezium, 1 over 2 A plus B multiplied by the height. So this is the formula of the trapezium. Okay, so we do the same for this. Okay, so for this situation, this is, if we read the scale, this is 45. And then here is going from 10 to 30. So this is 20. The height is 18. Yeah, okay. So these three numbers. Okay, so it will be 1 over 2. Okay, A plus B, 20 plus 45 multiplied by the height, which is 18. Okay, so if we calculate with the calculator, so 9 multiply 65. Okay, so that will give us, okay, 585 meter. Okay, so that's how we solve these kind of questions. Okay, next, calculate the acceleration in part C. Okay, so now we want to focus on part C. Okay, this one. Okay, so part C. Okay, so part C. So first we can see is the slope is going down. Okay, so which means it's deceleration. So means the answer will be negative. So this is the first thing that we know. And then acceleration means gradient. So we need to know this part, which is 18. And then this part is 30 to 45. So this is 15. So this is 18 divided by 15. Okay. Okay, so that will give us 1.2. Negative 1.2 meter per second squared. Okay. So if it is deceleration, means it's negative. Okay. Next. Yeah. Okay. So same. And yeah. Okay, so now we already finished the section 1.2. Yeah, so next will be 1.3. Okay. Um, yes. So 1.2 already finished. So we will go through these two questions and then we are done for today. Okay, so we go through these two questions and then we are done for today. Okay. Um, okay, let's take a look. Runner A runs 100 meter in 20 seconds at a constant speed. Sketch this information on a distance time graph. Okay, runs 100 meter in 20 seconds in a constant speed. Okay, so how do we sketch this graph? Okay, so first, okay, we will draw the axis. Step one. and then distance time. So the time is in second. Okay. Label the axis and give the unit. Okay. And then the y-axis will be distance. Okay. And then the unit is meter. Okay. Meter. Okay. So now we label the scale 0, 10, 20, 30, something like that. Okay. And then the y-axis, okay, maybe we can label like 20, 40, 60, 80, 100, something like that. Okay. So now a runner run 100 meters in 20 seconds. Okay. So we'll plot this in 20 seconds. Okay. We run 100 meters. Okay. So that is our speed time graph. Okay. Just like that. Okay. So this is what we expect to answer. Calculate the average speed. Okay. So this one, average speed equals to distance divided by time. So distance 100 meter, time 20 seconds. Okay. So that will give us 5 meter per second. Okay. Straightforward. Okay. Now runner B, okay, is twice as fast. Okay. Add a line to your distance time graph and label it B. Okay, so just now, this one is runner A. This is runner A. Okay, assume they also run at constant speed and run 100 meter. Okay, so now, what is going on? Okay, runner B is twice as fast. Okay, so also running 100 meter. So just now, this 100 meter, it take 20 seconds. This is twice as fast, which means 100 meter is only taking 10 seconds. So which means the runner B, it will be like this. 10 seconds and then reach 100 meter. Okay. So our line will be like this. Yes. Okay. So this is runner B. Okay. So this is how we answer this question. Okay. So if we look at the marking scheme, checking our answers. Okay. Yes, part A. The graph, runner A, runner B. Okay. So runner A, 20 seconds, run 100 meter. Runner B, he only take 10 seconds to run 100 meter because he's twice as fast. Okay. Average speed. Okay. Total distance divided by total time. Okay. So this is the formula. 100 divided by 20 equals to 5. Okay. C. Oh yeah. So C is what we did just now. We label for the runner B. Okay. The line show in the image. Okay. Question 6. Okay. A bus accelerate as a constant rate from standstill to 15 meter. Okay. Yeah. So this one, yeah. So this is a good question. So you can also think about it. Okay. So you can think about it also. Accelerate at constant rate from standstill to 15 meter per second in 12 seconds. It continues at a constant speed of 15 meter per second for another 8 seconds. Sketch this information on a speed time graph. Okay. Yeah. Okay. So we can try again. How we should sketch this speed time graph. Okay. Okay. Our axis. Okay. So in the exam, you need to use ruler, yeah? Okay. Yes. So we have speed time. So we have speed, which is meter per second, the unit. Okay, we always label with the unit. So the time is seconds. Okay, so we can make a scale of 0, 5, 10, 15, 20. Okay, and then this scale we can also make it 5, 10, 15, 20. Okay, now accelerate from a constant rate. Constant acceleration means straight line. From standstill, from speed of 0 to a speed of 15. Okay, so which means we need to plot 2 points. Time equal to 0, speed equals to 0. We need to plot 2 points. Okay, the second point, time equal to 12 seconds. And then now the speed is 15. Okay. Yeah. So the first point is here, 0, 0. And then the next one is time equals to 12, somewhere here. And then speed equals to 15. Okay. And then because it's a constant acceleration, so it is a straight line. Yeah. Constant acceleration. And then continue at a constant speed of 15 meter per second for another 8 seconds. Okay. So now, constant speed means the speed is not changing. So it is still 15. So the speed is still 15. Now the time is for 8 seconds. So now it's increased another 8 seconds. So now we reach at 20 seconds. So our next point is at 20 seconds. Okay, the speed is still remain at 15. Okay. Yeah. So this is the speed time graph. Okay. Yeah. So this is quite important. We suppose we can create a speed time graph or distance time graph from a description. Yeah. Okay. So we can see the marking scheme is like this. Okay. So this is what we expect to sketch. Okay. B. Use the graph to calculate the total distance covered. Okay. So as we mentioned before, the total distance is area under the graph. Area under the graph. Yeah. Okay. Area under the graph. So now, same as before, this is a trapezium. Okay. So trapezium, we will use the formula of the trapezium. So, okay. So this part is 20, 0 to 20. The height is 15. And then this part is 12 to 20. This is 8. Okay. So we will use the trapezium formula 1 over 2 a plus b multiply height. 1 over 2 a plus b 8 plus 20 multiply height of 15. Okay. So if we calculate everything correctly, that should give us a distance of 210 meters. Okay. Next. Yeah, so you can do it in 2 ways. If you cannot remember the formula of a trapezium, you can separate into one triangle and then one rectangle. Yeah, okay. And then you can plus them together. Okay. So example. So you have one triangle and then one rectangle and then you plus them together. So this one triangle is 12, 15. So this one is 8 and then 15 and then you plus them together. 1 over 2, 12 multiply 15 plus 8 times 15. Okay? Okay, 8 times 15. Okay, so if we calculate that, that will give us, okay, so this is 90, 15 times 8, 120, so 210 meter. Okay, so you can do it in two ways. Okay, final questions for today. Acceleration for the first 12 seconds. Okay, so acceleration for the first 12 seconds, which means we need to calculate the gradient. Yeah, okay. So coming back to our graph here, we need to calculate our gradient. So this height is 15. So the time taken is 12. Yeah, so we just take 15 divided by 12. Okay, yes. Okay, so if we calculate correctly, yeah. Sorry, my mistake. We missed out one question. Calculate the average speed. Okay, we finish this acceleration first. Okay, so this acceleration, 15 divided by 12. Okay, this is 1.3 meter per second squared. Yeah, so this is acceleration. Okay, now this average speed is total time, no, total distance, okay, divided by total time, okay. So total distance, just now we already calculate 210. Okay, total time from start to finish, okay. So average speed, we don't care what happened in between. We go fast or we go slow, we don't care. We just take the average. Total distance divide total time, which is going from 0 to 20. So that will give us, if we calculate correctly, okay, total distance divided by total time, 210 divided by 20, that will give us 11 meter per second, two significant figures. Okay? Yeah, okay. So with this, the time is perfect. We already finished until 1.2. Okay, so coming back to our progress here. Yeah, so okay, so basically our physics is still in progress, both for the textbook and workbook, no problem. So we will continue tomorrow. Yeah, so for the lesson plan, so basically the chemistry is completely done. So the physics is a big topic, so we still ongoing. Yeah, okay. So we will continue tomorrow. Okay. Yeah, so
Mm.
basically we finish for today. So if no question, we will stop here. Yeah. Okay.
Yeah,
No question. Okay. All right. Thank you. Bye
thank
bye.
you.
Thank you. Bye bye. Okay.